everybody, and welcome to our electrical systems webinar today. For those of you that do not know Rael, who will be teaching it, he is a wealth of knowledge. He was a home inspector for over 15 years and did construction prior to that. Just so you know, a few administrative things. If you have any questions, put them in the Q&A, and then at the end of the 30 minutes, Rael will be sure to answer them. And this is the, third of our virtual inspection webinars. We actually have videos for the crawl space and roof. You guys can reach out to me and send me an email if you want to see a copy of those webinars. And I hope that you learn a lot today. So go ahead and take it away, Rael.
Okay. All right, folks. Well, thanks for joining us today. And what we're going to do today with our electrical webinar is we're going to go through some slides, show you what you could perhaps look for or understand what comes up in your inspection report. So let's jump right on into it with some illuminating information. So let's begin with the service drop. So the service drop, it actually comes from the pole out in the street to the home. So we're seeing here in this particular case, we have a mast on the outside of the home that sticks up above the house. And that service drop comes in from the utility pole all the way through. Now, the other alternative, of course, is if you have underground electrical supply, then you would not see this mast here. But we're dealing with the exterior, some of the older homes, and this is above ground. So we have our service mast, the cap on the top, and we have what we call the service entrance conductors. So this is the main wire that's coming in from the street. And what we require here is what we call a drip loop. So you can see the way the angle is at the bottom of this wire right here. And the whole idea is that any rain or that's coming down obviously from outside, or even running down the service drop conductor, that it would actually drop off the bottom of the wire and not be entering into the splice area here, which would cause a shortage. So we move on to the next one here. These are the clearances that are required in the US. So coming from the utility pole, if we're on the roadway, we need to have a minimum of 18 feet. Over a driveway, we need to have 12 feet clearance. And if we have a two-story house, is a flatter area here on the home, 8 to 10 feet. And then we've got the mast here, which is actually 18 inches above the roof line. Down here, if we have a swimming pool, we need 18 feet there too, at least 3 feet over the peak of the roof here at the pitch, and 10 feet over a walkway. And again, the roadway, as in the previous picture, 18 feet. So that's something that we would actually look at when we step out of our vehicle. And sometimes they're hanging low. If there are a lot of trees down in the area, there might be some something that needs to be done with the branches if they're too close to the actual main wire coming in from the utility pole. We'd probably recommend some clearance there, some cutting back of the actual trees there to try to stop a problem before it starts, perhaps in winter when some of the branches might break off, or in the summer if there's a big storm, to break off and hit the wire and damage, therefore causing a power shortage. So here we're looking at a picture from one of our inspections. You can see that here we don't have an actual U shape that we require for a drip loop. It's pretty straight here, so any water running down this line right here would probably short out, cause a problem right there. So we're always checking for these connections as well as the drip loop. And this is right here, the connector. So instead of having the mast on top of the home like we saw here, where it sticks above it, this one is actually underneath the soffit, and it's attached with a head right here to the side of the home. So we'd make sure that this was properly secured to the side of the house. Here's another one where you can see it's actually the complete reverse of a U. Now we're going over the top, and we really need that to be brought down lower right here. Again, here the mast is attached to the side of the home, and the wire goes in through this hole right here into the attic space, and then over to where the electrical panel would be. Okay, so what's also important is about clearances is around the windows. It's funny how folks tend to think, well, if I can touch it, what's the result I'm going to get it? And it's not good. I mean, you figure out how many volts are coming down this main wire right here, which is going to power up the whole house. When you're looking at 100 amp minimum on a smaller electrical panel, all the way up to 200 amps on one of the larger panels that we have in our homes today, you don't want to have anybody going out there and grabbing a hold of that wire. Here's a picture taken, from one of the inspections where literally here, of course, you can see there is no drip loop at all, number one. But number two, it's so easily reachable through the window. And we don't want anybody putting their hands anywhere near that. Best suggestion here would be to secure the window shut and then, have that as a safety measure instead of just leaving it totally exposed like that. The main electrical disconnects can be located in two locations. This is pretty typical for an older home where you have it right at the meter. There was a disconnect in that little panel that's there. So when you're walking around the home and you see where the meter is located, usually it's going to be on the side of the home. In this case, it's up front. Sometimes it's around the back, just depending on where the shortest distance was from the utility pole or from the source of the electricity to the home is where we would find that main electrical disconnect. The other possible location for it is in the actual breaker panel itself. And this is more common in more modern homes. Some of them actually today have one on the outside and one on the inside. I'm not sure exactly why they started doing them on the inside. A thought had been perhaps, well, hey, if I went on the outside, I noticed that the house was empty for a while. Maybe folks were out of town. I could cut off the electrical system on the outside and therefore perhaps do away with the alarm systems that were inside. That would have been fine, except usually a modern day alarm system has a backup battery that's good for a couple of days at least. So, but they were moved to the inside. And it's a lot more convenient that way. In case of an emergency, you wouldn't even have to go outside. You could just be inside the home, your basement, a kitchen, a garage, and disconnect right there in the actual panel. The common problem with service size would be too small. And as we're using more and more electricity for our TV, for our laptops, for our desktop computers, sound systems, lighting, whatever we're using. Back in the day, 100 amps was pretty common, and today it's the minimum acceptable for most homes. And so, as we said, the more stuff we need, the more power we need. So pretty much today, 150 amp and a 200 amp service is not uncommon. Sometimes you even have more than one. Several homes over 3,000 square feet, you could easily have a 200 amp main panel, 150 amp or even 100 amp sub panel to do, if somebody, for instance, built their home and had an unfinished basement and they hadn't wired the unfinished basement, you would need more power if you had just a nice, perhaps a television room down there, a playroom, just a fun place to be. And you'd need more power in order to wire it all in. You would need to have a sub panel. And depending on how much equipment you were actually planning on putting down there would determine how much more power you needed and how big of a sub panel you need or an alternative panel you would need. So back in the day, let's look at this little schematic here. On the bottom right, we have a main hot wire and a neutral wire. And this wiring was actually called knob and tube. So for those folks who are familiar with older homes, this would have been the original electrical supply in the home. The actual covering on this type of wiring is now had such a long time since like pre-1945, we're looking at brittle, fallen away, exposed wiring here. And if we find it during our inspection, we'd want to have that removed. We would test it to make sure that it was actually active. But even if it's inactive, if it was possible to get to it fairly easily, it'd be a good idea to have that removed, just so that it wouldn't come up as an issue on a resale perhaps 10 years later, where an inspector would go in and find some of this knob and tube, and then the existing owner would be perhaps requested to remove it. So older style cable, it had a cloth outer sheathing, but it had no ground. So you can see here, as in the knob and tube, it was just a black wire, hot wire, and a neutral. And that's how we came up with those two-prong electrical outlets that are so common in houses from pre-1965. Oops. Then we went on to more modern cable, and this is what we see today in most construction, is the modern cable has a plastic sheathing to it. Again, it's a two-conductor, the hot wire, the neutral, and this one has the ground wire in it. And this was used after the 1960s and is still used to this day. Then we have for the 220 circuits for our electrical dryers, and an even more recent upgrade for our motor cars that are in the garages. They are now building homes that have a plug-in for our electric vehicles that can recharge the battery perhaps overnight. So again, it has the plastic sheathing and stuff. And so, what we have here with this original, since the 60s modern wiring, is the changeover from the ungrounded outlet, which would have had just the hot and the neutral wire, to the grounded outlet. When anybody's doing these renovations and they're coming in and they're removing the two-prong outlet and turning it into the three-prong outlet, you would assume correctly that it was a grounded outlet. And that's why we do our inspections at Home Probe by testing every accessible outlet, simply because many times these electrical outlets have been changed during a renovation, but the wiring has not been changed and the outlets are not actually grounded. So what happens then is you plug in your computer or your very expensive TV, and there's a power surge through lightning strike, and your system is totally fried, simply because you thought you had a grounded outlet and you did not. So the way you can check that is by having one of these testers. You see the two of them are different. This one over here is pretty much like a homeowner's type outlet. You plug it on into the electrical outlet, and you can see right here it says correct. You'd have these two little lights would light up. If you had a reverse, and I'll explain that in a moment, you would see how you would have the red button and a yellow. This is an actual hot and neutral reverse. So that would be the neutral wire would be normally where the white wire would be, and that would show up like that. If there was no, if there was an incorrect connection between the hot wire and the ground, then it would show up with the red and the yellow like that. It's really kind of a really neat little tester to have. They're around $10 at your favorite home store. Open hot means the hot wire is not connected in there, so nothing would show at all. And then you have the open neutral would be the yellow, and then the open ground would be the little yellow in the center. So this is, you can see this is a three-prong, so it would go into that three-prong outlet, and you'd be able to see exactly what any issue was on a particular outlet. A reverse polarity is very easy to repair. It's just a removal of the actual plate, outside cover plate, pull out the electrical wire outlet and switch them on over, and you'd be okay. Suggest somebody who really knows what they're doing with electrical, or certainly if you want to do the handy person type thing, make sure you do actually shut off the power at the meter or at the panel box, and make sure that is certainly no longer active outlet before you go in and start handling the electrical wiring. The one that we use is, that would be similar to this. And again, you see the same type of thing. We see the correct on the bottom with 2 yellows, etc. But this red button is what we use, especially in kitchens and bathrooms that have been remodeled. And this little red button would tell us if that ground fault circuit interrupter, that GFCI, that's supposed to trip when it's near water. The GFCIs are located at the kitchen sink, at the bathroom sinks, wherever they're near water or on the exterior of the home. This little button here creates a shortage. And when it creates that shortage, it pops that button. So many times you could go into, for instance, the bathrooms and push one of the red or black button, and the button would pop. And everybody would think that you had a grounded outlet there. In actual fact, that's not the way it works. But these electrical little buttons right here would actually cause to trip, would cause an overload, and it would trip correctly. So when we would test with these testers, and then perhaps it wouldn't reset, and then we would know that that particular outlet was not really grounded. It was just a GFCI that was placed there, and therefore it would have to be repaired. So you would look for that in your report under the electrical system on recommendations, that it actually is repaired by a qualified electrician. So here we talk about overcurrent protection. So overcurrent protection is basically a fancy word for fuses and breakers. So in the older homes, you can see here we had an original fuse panel, and we had some pull-out fuses as well. And then we had a sub panel that was breakers. So this is the newer panel on the right side. This is the older panel on the left side. An interesting fact is, I had, besides my construction background, I had a lot of rental property for a while, back in the late 70s through the 90s. And we had a lot of the older homes that we'd bought that had these fuses, and we turned them into rental properties, and it turns out to be great. But the folks that are renting there sometimes might not really, tell you if there was an issue, that they kept on blowing a fuse. And the word got around pretty quickly that if you took something simple like a penny and you put a penny into that slot before you screwed the fuse into it, it would actually negate the fuse from blowing if the overload happened in that particular case. So basically what you were doing is you were putting in a penny to put your life in danger, instead of letting that fuse pop and walking to the corner store and picking up another one for about 25 cents. It's very common back in the day. One of the reasons actually I was happy to get out of that kind of business, because you were looking at a fire hazard at any given time. So here we're looking at, talking about the service box, the grounding in the panel. This is under the electrical section of our report. We would recommend, or certainly give you the information, that the fuse style electrical panel is older and obsolete equipment. While the panel may still be in good and serviceable condition, it's recommended that all conditions outlined in the report be repaired or evaluated by a qualified electrician. And a short-term recommendation, where insurance is not an issue and the panel and the wiring is serviceable, GFI outlets or breakers can be provided as an interim safety improvement before replacing the system. Cost for GFI outlets may be roughly $100 a piece. One GFI protects one circuit. The long-term recommendation would be to replace that fuse panel during renovation or remodeling products. And you're talking about $2,000 and up. Now, hey folks, there is no requirement for anybody to bring up the home to current code. That's just the way it is. So if you're buying an older home and we're talking about bringing a house up to onto current, current code, that's not really something that, you can negotiate it, but it's not required to be done. If the actual electrical work was done according to the permitting and according to the inspection and according to the code at the time it was done, then that's fine, and it would be applicable to that time. So there's really no requirement for anybody to upgrade. Perhaps the buyer would want to do that for safety, and that's certainly recommended, and that's why we would put this particular comment into our report. So here we are, we're looking at a very clean electrical panel with our fuses. One of the interesting things is, why do we take off the cover? And we'll cover that in just a minute. But in here, you can see that in this particular case, both here and here, we have 2 wires coming into each fuse. And that is an absolute overload immediately. That should not be happening. What's happened here is we have an electrical panel that is too small to handle whatever extra electrical has been added in. And so they've gone ahead and put in these extra wires onto that particular fuse. Now, bear in mind that you can see these are all 15 amp fuses right here, the blue ones. The larger one is a 20, and there's a 30 up here. So you can't take a 20 and put it into the 15 amp fuse spot. They're sized differently. So the actual section that actually makes contact inside of this panel is smaller on the 15 than it is on the 20. So here we're looking at the standard breaker panel, and the main disconnect is right here in the electrical panel itself. Usually you're going to find this in a garage or in a basement. So we always remove the panel cover to examine the interior of the panel. So we can check the wiring. We want to know, is the right size wire going into the breaker for that size? So the typical thing that you would find is, if you had, for instance, a 20 amp breaker and a wire that would only handle 15 amps worth of current, what would happen to that particular breaker when the power was coming down, it was pulling too much? Well, it wouldn't trip the breaker simply because the wire would heat up and perhaps flame out and cause a fire in that particular breaker. So you want to make sure the breakers are, in actual fact, sized correctly with the size wire coming into it. Here we're looking at our fuses again. These arrows were showing that the fuses were blown. This one in the center is the main disconnect in this older fuse panel. By pulling this on out, you would have 2 very large tubular fuses behind that disconnect, and that would cut the power to the home. So we talked about those double tap circuit breakers. Here we see, instead of the fuses, we've got a circuit breaker, and we see the 2 wires coming in to that. So what happens then, if you've got a coffee maker and a blender perhaps and a toaster all going on the same circuits on your countertop, likely you're going to cause that circuit breaker to trip because too much power is being pulled out of that particular location. So yeah, changing to components in our home are ongoing. So newer and upgraded safety and convenience devices are always being upgraded and brought to the market. So an example is the grounding of the electrical systems, the introduction of the GFCIs, which are, of course, we mentioned bathrooms, exterior, and in kitchens near water, as well as arc fault circuit interrupters. So here we look at our standard GFCI breaker, and that was what I'm talking about with the red and the black buttons that would actually trip. So they were required beginning in '71 on the exterior and at swimming pool equipment, and then later became a requirement in garages and kitchens and bathrooms. And then we moved up to, in 1999, arc fault breakers. And these were for new construction renovation projects, a lot of times in bedrooms. Is where these were located. Just kind of some of the things that we see on the inspections. This is an outside light switch near our screen porch, and it doesn't have a weather cover, and it should have one, so that would have been called out, as well as perhaps an electrical outlet that's on the exterior that would be exposed to rain and the weather. Also, it's really important about building permits. When you're doing the renovations, were permits taken when the reno was done? So here we're looking at a home that perhaps had an overhead light above a medicine cabinet back in the 50s, and it had a little 2-prong plug-in for electric razor or a hair dryer back in the day. Before they became 3-prong required units. And they didn't put in an electrical outlet, which is required in the bathroom, not only electrical outlet, but certainly an electrical outlet in the form of a GFCI. Here we had a renovation done. So we're looking at this home for sale, and somebody's been a handy person or had a handy person come in and put up some paneling in this basement area, but no electrical outlets were installed, and they are required on each of the walls, and there are restrictions on how far apart, etc. So this would be basically called out that there were no electrical outlets present, and that they should be installed by a qualified electrician. I mean, don't use a strip extension cord for anything, neither for a overhead garage door opener or for a refrigerator plug-in. And this is basically, you can see down here, there's a trip right here for them. So it's working on an extension cord with a resettable trip device. I guess the reason why they did that was because it would be tough to pull out that refrigerator, reset that button if it did trip. There also might be a water line connection back here for the ice maker, perhaps, or water dispenser. Would have been a better idea to have the GFI or even just a regular electrical dedicated outlet behind the refrigerator and had a GFCI out here somewhere closer to the sink. So what about this one? Are they missing altogether in this kitchen? In actual fact, that would have been the first impression, but we're looking at more than just what we see on the bottom level. We're looking up here too, and these were under the cabinets. A lot of folks are doing it these days. Get a nice clean look. So the electrical outlets were actually underneath the wall cabinets here. We've got to have access to our electrical panel. And the requirement is 3 feet by 3 feet, 3 feet wide, 3 feet deep. We have to have clear access to that panel. As you can see here in this pantry, this one is behind all of the shelving, and we do not, as inspectors, start taking shelving apart, moving all of this stuff to get to it. We need direct access. In a case like this, it would be called a limitation. And with that limitation, we would request that all of this stuff be removed, provide the access to that panel, and we at HomeProbe would come back to this location for free and finish that little part that was not accessible and add it to the inspection to finalize it on out. Another thing right here, it's all very well to do our renovations. This cabinet was put in right close to the panel. I would imagine you'd be able to open that panel and reach back there in order to reset a breaker. But if there was any repair work needed to be done in this panel, or if new wiring had to be brought into this panel from either below or above, you would not really be able to access it without having to remove that piece of cabinet. So, again, it would be information, and it would be up to the client to decide, what they wanted to do about that. It would be pretty expensive to actually move that electrical panel over. There might be another alternative, perhaps on the other side of this wall. There might have been the garage. But if that was the case, perhaps the panel could have been flipped around to the other side and not cost as much, and certainly have the access that would be needed. Openings in the electrical panel should all be filled, so they should be all filled up. There are actually little plastic inserts that can be installed in here to secure these completely shut. Amazing how critters do get in here. One surprising experience of taking off a cover one day was a squirrel that had gotten in there. Unfortunately, the squirrel wasn't grounded, and he was kind of crispy critter when we saw him. Again, just plain openings. They're called blanks, and they come in several sizes that could easily fill this opening. We don't want anybody being able to put their fingers into these opening spots right here in the electrical panel. Lots of other little odds and ends that we find. Top left here, how simple is it just to put a cover over that? There are a couple of dollars a piece, and you can see the screws are right here. So we just need a cover on that. Same thing up here in this attic, a little plastic cover over those to keep from any sparks coming out of here in case of a shortage. This is what we call flying splice, where just tape had been used to put all this stuff. It's kind of a hazardous condition. We want to go ahead and put that into a junction box here. Same on this side right here. We just had wiring that was connected with some wire nuts, not even any tape, anything. Go ahead and put it into one of these junction boxes and have it secured, and it'll be in a whole lot better shape and a lot safer. There's several type of breaker boxes that are no longer no longer safe, so to speak. So one of them is Federal Pacific, and they were installed from about 1950 to 1990. And over the years, have shown that about 1 in 4 breakers will be defective, and they are not properly tripped. They cause a fire hazard. We don't actually open any of these particular breaker panels simply because of the defects that are inside there. Might create electrical shock for us when we do that. Zinsco was a popular panel brand, and with very few breakers in operation today, and it was found that they would allow the electricity to burn until the wires melted, and leaving the house in risk of fire or shock. And Sylvania, don't see too many of those Sylvania panels around. There were also, sort of a brand name made under Zinsco, and then the ITE Bulldog Pushmatic, same thing. And this is kind of what they looked like. The Federal Pacific had like a little red tag on the left side here, and here we have a Zinsco with its blue tag and main breaker. So that's kind of what we looked at with the panels. Most important, of course, what we talked about was the grounding. Very common in the old days, 50s. Was when we had galvanized steel or copper coming in from the street. The main ground wire from the panel would be able to go to the water pipe, so we would be grounded there. A lot of grounding poles on the exterior that were driven 6 feet into the ground, and then the wire could be attached there. But what's most common today when we're building on a slab or with a poured concrete foundation, that rebar that would go all the way through the foundation into the dirt is the common way of finding it. The way we would locate those locations would be typically in a garage or some other location nearby to the meter on the interior of the home, where it would be basically a double double outlet cover that was totally blank. We would remove that cover, we'd find that connection, and then photograph it and include it in our report to show where the grounding was. Not that you would ever need to go there, but we would just prove that the grounding was actually connected, and that would be good to go. If these things were not taken care of, if there were electrical issues out there, you don't want this to be the result. So electric shocks do happen, and if you're not done correctly and we're not giving the information to help you to solve these issues, then this could be the result. So thank you for joining us for the short webinar. If you do have any questions, please do share with me, and we'll get to them right now. And Barbara will jump back in and give us a little bit of more info, and then we'll jump right to the questions.
Yeah, Rael, you can go ahead and do the questions. It looks like there's some in the chat and some in the Q&A. So do you have the ability to see those?
Yes, I do.
Okay, so, why don't you go ahead and do that?
Okay, so let's see a second. So John, yeah, the wiring that goes over to the swimming pool would actually be in a encased tube, and it would be underground. It would not be above ground. So yeah, they would allow the wire, but it would have to be buried. I hope that answers your question. Are GFCI tested when the resets are located in the breaker box and not just, yes. We're always going to test, to Leanne, we're always going to test all outlets. Unless we have to move big furniture that might involve some damage to the furniture or to us, we are going to get to every electrical outlet. So not just the GFCIs, but all of them. Hope that answers your question. Do you need a GFCI in the laundry room? Is it possible to test by just pushing the red? Yeah, that's the whole thing. You needed the tool to actually test. You don't, just pushing that red button doesn't really tell you whether it's grounded or not, Holly. One more. Don't have a power meter. Is the electric company monitoring of it? No. I don't know why you don't have a power meter. The electrical company these days actually have a way to tell you usage, because the newer electrical company meters actually have a chip in there that monitors, and that the guys don't have to come necessarily onto your property anymore to get the reading from the meter. They're able to just use their whatever they have on their cell phone or their meter reader from a distance from the street. So perhaps a power meter is a good idea. John, I'm not sure how you're getting the power in there without the electrical meter. Perhaps you could explain a little and I could answer further. In the meantime, let's go over to the other. GFC outlet tested when the resets are located in the breaker box and not just in the outlet themselves. Yes, so we did mention that. A smaller wire going into a larger breaker could cause a fire. It would be okay to have a larger wire go into the small. Well, that's the answer to that, Michael, is that the breaker would not trip because the wire would not get hot enough to cause it to trip. So you don't want to have the larger wire going into a smaller breaker either. What you want is them sized correctly. So you want that 20 amp wire going to a 20 amp breaker, a 15 to a 15 amp breaker, etc. Okay, we go back to, I think that was it. Did anybody have anything else?
It looks like John said, I don't have a power meter. Is the electric company monitoring over the power lines by computer through the main breaker, but no meter?
I don't believe, I've never heard of any of that kind of thing yet. Again, I've been out of inspecting for the last couple of years doing, CE classes and marketing for the company. So I'm not aware of that's even available. Perhaps we could Google that, you and I both. Yeah, perhaps, John, you've been there so long, they don't, are they sending you an actual bill every month? That would really be interesting. How they were able to calculate, or is your bill the same every month? Is it vary? Wow, that's certainly an interesting phenomenon right there. Something I've never heard of before. I would certainly, if you'd care to put in your email to Barbara, and it's not the same.
I can, I don't mean to interrupt. I can definitely get you his email. I have John's email, and you guys can
I'd be fascinated to find out that, how they're actually doing that, and maybe that would help you out some, because you might not be using as much power as they're claiming you are. So certainly, yeah, let me look into it and get back with you. Yeah, thanks for the questions. Anybody else?
Okay. And thank you to everybody that spent some time with us today. Be on the lookout for our virtual inspection that we're going to be doing at the end of the month. I'll be sure to send you an email. We're actually going to record one of our inspectors doing a full inspection, and it is 3 hours of CE credit. So thank you again for your time. And John, I'll hook you up with Rael. And I hope everybody has a fabulous weekend.
Thanks, everybody.